right, so we've done confidence intervals with large samples. Now we're going to take a look at confidence intervals with small itty bitty samples. So this is for confidence intervals for sample sizes less than 30. So let me show you what's going on. So if you take a look at what I've already uploaded, this confidence interval equation sheet, we already have this listed on here. So we've already taken a look at large samples for n is greater than or equal to 30. So we've been playing with that one for over the last 2 days. Now we're going to take a look at what to do if you have a small sample. This does the same thing. We're going to be able to predict a population mean, but this time we only have to talk to a few people, okay? So let me show you how this works. You'll notice that it's pretty much identically the same equation. The only big difference is that it uses what's called a critical t-score and not a z-score, okay? So I'm going to go back real quick, and if you take a look, I have linked also this t-table, which is what you guys have been using for the z-scores. I'm going to now tell you a little bit more about these critical t-scores, okay? So in order to do this, I'm going to show you guys a quick example. So I wanted to figure out the average amount of time my baby sleeps when she's taking a nap. Now normally babies should be sleeping at least 45 minutes or more, but my baby for some reason does not like to take naps, and really she only sleeps a little bit of time. So to be honest, all these numbers are a little bit hypothetical. She really on average probably only sleeps about a half hour per nap. But let's say for instance that I sampled 8 times she's taken a nap over the last couple of days, and I want to just out of all naps figure out what her average sleep time is, so her population mean. In order to do that, first of all, I'm going to find a couple things. So I need to get the average of my sample, so my sample mean. So I'm going to do that real quick, doing my normal average on Excel to go ahead and get that mean. So there's my mean. That's my sample mean. I'm going to get my sample standard deviation as well. So I'm going to go ahead and get that. Now you might be wondering why I'm using that particular formula. I have an older version of Excel, as you guys can tell up here. And this does the same thing as the one you guys have been using with the .s. It still does the sample standard deviation. So there is my sample standard deviation. There is my mean. Now, my sample size and my n, or my sample size in this case again is going to be 8 numbers. So 1, 2, 3, 4, 5, 6, 7, 8. So there you go. And then last but not least, I need a confidence level. So in this case, I'm going to do a confidence level. Let's just do 95%. So I'll have a 95% chance that this prediction is actually correct. So let me show you how this whole t-score thing works. So at this point, it literally has been the exact same problem as before, and it's going to use the exact same equation, but we just need to figure out a t-score that works for this. Now, in order to do this, you'll take a look at this t-table. There's the confidence level, which again you've been using to match up your z-scores. Now to get the t-score, that's all these numbers up top here. And what I want you to pay close attention to is the column over here with the little DF on the top, and that has all those numbers listed below it. What the DF stands for is degree of freedom, okay? So I'm going to just write that down. What you need to figure out is the degree of freedom, or your DF, and again that stands for degree of freedom. And the degree of freedom honestly is just a fancy word for one number less than your sample size. So to figure out what your degree of freedom is, you literally just take your sample size minus 1. Okay, so in your notes I would probably write that DF is equal to n minus 1. So in this case, my degree of freedom, so I can figure out my t-score, is going to be 7, because 8 minus 1 is just 7. So to find out my t-score, I'm just going to go over here to my t-table, and I'm going to go to my 95%. That's going to be the column that I use, and then the row that I'm going to use is that 7, or my degree of freedom of 7, which again is 1 less than my sample size of 8. So that 2.365 number, that's my t-score. So I'm going to write that down here, 2.365, and that is going to be the number I use for my margin of error formula. So to get my margin of error formula, I am going to use that same formula I've been doing before, but instead of a z-score, I use a t-score. So it's going to look something like this. My t-score value times, I'm going to put a little parentheses in here so it does the order of operations correctly. Standard deviation divided by the square root of my sample size. And that should give me my margin of error. So my margin of error is going to be 17. To figure out my actual mean, I'm going to add and subtract that number to my sample mean here. So this number, my sample mean, I'm going to add and subtract the margin of error to that number. So let me do that real quick. So I'm going to do 47.5 plus that margin of error. So that's 64. And then I'm going to do 47.5. I don't know why I don't just click these boxes. Oops. Minus that margin of error. Boink. So between these two numbers, that's going to be where the actual population mean is. Now you might be like, that's not that great of a prediction. It's kind of a widespread. Well, if you probably guessed it, I've only sampled 8 times, or my sample size is only 8. So how good of a prediction really is that? And that's really why the t-score is used and not the z-score, because if you take a look at each of these t-scores, they're always going to be bigger than the z-score that's below them. And that's because they're providing a little extra wiggle room because, again, you are using such a small sample size. Okay, so today's first assignment is going to see if you guys can look up t-scores correctly. Again, what you're going to want to do is match up your confidence level with your sample size, but again, we're not using the sample size, we're using one less than that, and that's our degree of freedom. So you're using the degree of freedom on the column there to figure out your rows, and then your confidence level, and you're matching up and finding the correct t-score from there. Okay, so hopefully this helps a little bit with today's assignment, as well as tomorrow's assignment will be a few more actual confidence interval problems using t-scores. Okay, if you have any questions, you can always drop by office hours every day from 1 to 2 p.m. All right, thanks.